So the next step is the internal interface scan. So if we turn our attention back to the RF interface and without doing anything, take a look at the signal. So the transducer at the moment is back to the home position, center of the sample, and I'd expect a die to be inside there in the center. So if we look at the signal, we see the top surface as normal, and then we see a slight ripple at around 0.45 microseconds in time, and that's probably the echo from the top of the die. We'll just assume it is for now. What I like to do is increase the gain a little bit to help make it more clear. There we go. So that's probably the echo we need to focus on. So let's go ahead and focus back to the transducer control window. Bring the Z-axis down. Again, I'm pressing the middle button for slow movement. Back up again. More or less there. So I'm now focused on that echo there, which I believe to be the top of the die. Focus complete. Now we move to the gain position. Like I mentioned before, I wanted to perform a multi-interface scan. So not only did I want to see the top of the die, I want to see the other structures as well, including mold compound to substrate. So if I make a wide gate position, I'm just guessing, something like this, that should catch the mold compound to mold compound to substrate interface as well. So that's the focus done, the gate position done. The third thing is the gain adjustment, and just like before, increasing the gain to around 60–70%, good starting point. Start scan. So we can see the substrate level now, the copper tracks in the substrate of the BGA. So if I bring the mouse over, so this area here is between mold compound and the substrate, and then on the outside here is the exposed substrate that we can see with the naked eye. So now we can see internally, and there appears to be a huge popcorn type crack or delamination. You see the bright region. First of all, it looks abnormal, and then with the bright colour, that's also giving us an indication that there's a delamination there. So we can apply a colour map to this image to help enhance the defect, make it more clear. So if you just double click on the left side here, you get the colour map window, or you can click the icon up here, color maps, and choose your appropriate color map. I'm going to go with one of the classic color maps, positive echoes of grayscale, negative echoes yellow and red in this case, and it works really well with plastic molded devices to clearly identify the defects. So if I quickly go back to the RF interface just to finish up, we can also see the image window as well on the screen, which is good. I'm just going to move the transducer over to the large red area, and here we can see the big negative echo where we go from mold compound to delamination, negative echo, and compare that to, I'll just move to the right side where it's grey. We have a positive echo, so we're going from mold compound to bonded substrate. There's a nice small positive echo there, so some energy has been reflected back, some energy is being allowed to penetrate deeper within the sample. Compared to where the delamination is, we have a bigger amplitude because all of the energy is coming back at the delamination and there's zero transmission. So that concludes our quick basic setup tutorial. Thanks very much.